Good afternoon, ladies and gentlemen. My name is Hector Lucatero.
And my name is Richard Conway.
Tonight we'll present to you guys what the basics of a structure is.
As well as how loads are traced throughout a structure.
So, Conway, can you please tell me what a structure is?
A structure is any organized group of elements that will take a load and transport it throughout itself into another area.
So, some examples of structures are college dorms, office buildings, bridges, the Eiffel Tower. This as well is a structure. In a structure, we have elements such as columns, beams, and girders. This right here will be referred to as our column. A column helps support your roof deck and the whole structure vertically. Attached to the columns, we have elements called girders. These three right here will be referred to as our girders. A girders is usually a horizontal steel beam. Attached to those girders, we have beams right here. The beams are very important. The beams help support your roof deck and as well your floor.
So all of these elements work together to transport forces down throughout itself and into the foundation. So altogether, these would be a structure. Without each other, they would not be. So for instance, in this structure, this side table that we're going to be using tonight, when I apply a force right here, different elements transport the forces down into the foundation.
So behind us, we have a photo of a 5-story office building. So Conway, can you please explain this to me?
Of course, very much like this structure here. In this structure of the 5-story office building, we have columns and girders, but I'm not really seeing any beams here.
So if we don't have any beams, how is it being held up, Conway? Can you explain that to me, please?
Of course. So underneath, we do have a foundation, very much like in any structure, but then horizontally, how are our weights being distributed? Well, as we can see, we have floor slab systems. So although I'm sure there are beams somewhere in this model that we can't see in this view, there are going to be horizontal loads that are transferred throughout the floor slab. The floor slab is going to be a type of load that's going to need reinforcement due to the nature of concrete. And so we're going to have cable systems that are tensioned after the concrete cures, as well as rebar inside of these elements to help disperse that load horizontally to the columns.
In every structure, we also have what is called dead loads and live loads. A dead load is what is permanently on the structure that cannot be moved. For example, this is your roof decks, your HVAC system, the structure skin.
And live loads are anything that are able to move and are not permanently fixed to a building, such as in a parking deck, cars would be in different spots or at different capacities over different days. It can also include people, any type of furniture that's movable, anything within that building or that structure that is able to be moved or not as permanently fixed as a dead load is.
In every structure, there is always load tracing. Load tracing is how the forces are distributed throughout the whole structure. In this structure, we have a roof deck. The roof deck is forcing a vertical force down to the foundation. How it is being held up, it is because the column is having a vertical force on the roof deck. Alongside the column, we also have our girders and our beams. The girders and beams help out the column by giving it a horizontal force and reinforcing the entire structure of the building.
So, for example, these columns, girders, and beams are really at the base called those due to what they do for the entire structure. So if we were to flip this entire structure on its side, what were once our columns are now going to be our girders because they transfer loads horizontally, and what were once our girders and beams are now going to be considered columns and girders. So there's a identity change of our elements based on what their job in role in the structure is. So for example, if we were to place my arm here as an example of a downward force on our structure, my arm would be doing a uniform force against the top of the structure into the girder, and then from the girder, it would horizontally push that force outwards and down through each column vertically into the foundation. Say this is a footing. So as a load tracing example, Hector, if I were to place a very heavy HVAC unit or another large rooftop unit right here that was extremely heavy in this one corner above this column, where do we say that the load would be possibly traced?
Good question, Conway. If there was an HVAC system or a significant amount of weight in this exact corner, you can see we have a column right here. This column would take most of the weight from the HVAC system. It would distribute the force and the weight vertically down to the foundation. But let's not forget, we have other columns. These other columns also play a role, however, not as significant as this column. There's just a fraction of weight that will be distributed to the remaining columns as well. Let me ask you this, Conway. What if we have a weight in the center right here on the edge?
On the edge, okay. So if we have a weight right here on the center and edge, the weight will be distributed between the two columns on the forward face of the building, while there will be a small remainder transferred to the back via these girders on each side, pushing that weight or horizontally distributing that weight and that load to these rear columns, which then also relieve a small amount of that vertical stress that is left over from these two columns and what they weren't already transferring vertically down into the foundation.
All right, guys, to wrap things up, today we have learned about the basic elements of a structure, such as its dead loads, its live loads, how weight is distributed, elements of it, such as the columns, girders, beams, the load tracing.
And how all these, columns, beams, girders react have a full and encompassing effect on how a structure reacts. So we also talked about how if a structure is flipped on its side, how each of those beams, columns, and girders may switch its identity based on what they're being used for in the new orientation. So just because something's in a certain shape doesn't mean it is technically something. If you can reorient it, it'll be used to transfer a load maybe horizontally instead of vertically, or in any other example. So there are also other structural elements we did not talk about today, such as arches, cables, and different systems and how those can be used, such as like a cantilever, any of these types of structural elements. So we did try to cover just the structural simplicities of this example. However, I hope this gives you a good idea of what a structure, how a structure may actually work, and how elements in a structure work to accomplish their intended purpose of tracing and moving a load from one area to another.
Thank you, guys.
Thank you.